Hi everyone, we are from the group MEGAH and SDN.BHD section 3 of the course of BFC 34703 structural design. So today we are going to present the bin design for the two-story building. So here is our group member. First is Chris Ng, which is me, CF200139 nanometric, and Nuradila, Binti, Lile, then Haziq, Daniel, and then Mashe. So first is about the introduction of the description building. So we plan to design a new double-story resistant house for the hostel named Tunku Kusta, and it will locate at the Lorong Muda Parit Raja at the Parit Raja Johor. So for this project, our objective is to create a structural design layout of the ground floor, first floor, and the roof based on the architecture drawing we have, and also each member need to design the one simply supported bin for the first floor bin and one continuous bin for the first floor bin. So this is the architectural layout we have. So next is the structural layout we have designed. So here analysis we have determined specification we have determined for design the whole project. So include the material property specification and the characteristic action. So next I'm going to present the design simply supported bin I have designed, where I will design the bin of the 5-C1B, which is this. This is my calculation for the simply supported bin. So here is the specification, and the size I provide is this, so it's B and H. After that, here the C norm I provide is 25 millimeter. After that is about the loading. So this is the bin I will design, and it's just subject to the one span only. So after that, W I get is this value, and the maximum shear force and the maximum bending moment for the design purpose. So due to the K is greater than the K balance, so here is the compression rebar is request. So this is the value for the compression rebar I provide, and here is the tension rebar I provide, and finalize is really like this, the cross section. So it also need to make sure that the area provided is in the range of minimum and the maximum. So after that is the shear reinforcement. So for the shear reinforcement, the shear link part, so I provide this Haziq with the spacing 225 millimeter. So it's still available because it's less than the maximum spacing. But for the minimum link is greater than the maximum, so use the maximum only. So it's also the same value to the shear link for the minimum link will provide. So here is no need to calculate for the minimum link for the shear resistance, because along the whole span will be provide the same value, which is the H6 with the spacing 225 millimeter. Then the additional longitude, the value will be used in the detailing. After that, check for the deflection, so OK, and the cracking, and also get the OK. So here is the detailing. So for the detailing, here is the additional longitude just now we calculate. So we make sure that at the support is enough to carry the longitude shear. So 2H20 is enough to carry the longitude. So here for this we will provide the 2H20, and the mean span will provide the 3H20. And along the shearing will provide the same spacing, and here is the compression rebar, and this is the cross section. So that is the simply supported bin. Next, continue by the continuous bin. So for the continuous bin, so here is the size provide, minimum provide. So this is the bin I will design. So it's subject to the 3 span 1, 2, 3, and this plan will no subject because it's the one way. After that, it also have the 2-point loop. So here is the secondary bin, and it's also the secondary bin. So we'll have the 2-point loop. So after calculate, we will get this loop-case 1, loop-case 2, and loop-case 3, and use the step pro to get the maximum value. After that is for design the main reinforcement rebar. So it's same so this is for the compression rebar, and here is provide for the tension rebar, and then finalize the cross section will like this. After that is the shear. So for the shearing we have distributed to the 3 parts, which is, and each support will have the different shearing provide. So for the support 4 is critical because it's the maximum shearing. So after that calculate, we will use this. Then for the minimum link cost is also greater than the maximum then provide. So we will use this value for the minimum link. So after that is at the support 2A will provide this, at the support 5A will provide this shear link. So check for the link arrangements due to the the minimum link at here is sent. So we'll use the Haziq 300. So after that, the check for the deflection okay, cracking okay, and here is the final detailing. So because have the two lines, so for the mince man we'll use the 2H20, and for the smear, the under the bottom we'll use the 2H20. After that is the shearing and the tension. So here is the distance for the compression rebar. So compression rebar will distribute to the three parts. So 1, 2, 3. So we'll provide the 3 based on the specification provided. So that's all from me. Thank you.
Hi, my name is Nuradila Binti Lile, metric number CF200 and 200. I will present about my part for this project. I designed for two beam, which is simply supported beam and also continuous beam. For simply supported beam, I choose F1/34 beam. For this beam, I use rectangular beam, size 125 and H is 300. I use a sinom for 45 mm. For this beam, I consider for action from slab 1 and slab 2, which is slab 1 is one way and slab 2 only specifically for this area since it is two way. For the after the calculation area of compression, the compression I use is 2H and 10. Compression is 4H and 12. So the cross section is supposed to be like this. For the link I use H6 118 for this for the minimum link, since the minimum link is greater than it should be maximum link, so I will consider the same. The additional longitudinal reinforcement I use 2H and 12, which is 226 mm square. So calculate for cracking and deflection, both of it is okay, so should be no problem for the beam design. This is my detailing. Consider for the longitudinal shear. I use 2H and 12, which is 226. Supposed to be okay because it's more greater than AS request. Okay. For continuous beam, I choose 3H 3/H until E beam, which is to span. For the continuous, I still use a rectangular beam, which is B is 150 and H is 350. So sinom is 35 mm. So for the load and beam, I calculate only for slab 1, slab 3 and slab 4, which is I don't consider for slab 2, since slab 2 is not subject to the beam that I want to design. And since it's two-way span, so I use that pro for analysis. I got shear and bending moment, which is this. And for the compression I get 2H and 16. For the tension, I use 2H and 20. So the cross section in detailing should be like this. For the shear reinforcement, since my beam is 3 support, so I divide to calculate the 3 support, which is support F1, E, and also H. For the F1 is the critical, which is the shear force is the maximum. I use for the F1 is H6 until 150. And also this for the H, for the shearing, I use H6 and 200, and E is H6, and okay, this is my link arrangement. For after that, I calculate for cracking and also detailing. Request is lower than what it should be, so it's supposed to be okay. So this is my detailing for the entire beam, and this is the higher, because the basically the maximum is here, so it's a little bit higher. So this is the cross section for the beam. Okay, and that's all from me. Thank you.
My name is Mashe Sreenathan matric number CF200176 from Structure Design Section 3. Today I will be presenting my calculations on a simply supported beam. Following the project instructions and floor plan, I have decided to make an L-shaped beam with a height of 400 and a base of 200. And main reinforcement, it is supposed to be 3H12 for the reinforcement layout. Shear reinforcement, I've decided to use 6H 275. From the calculation of the shear resistance and minimum of length, I've decided to use 6H320 millimeters. ID actual is less than ID allowable, therefore our beam design is okay. For the top part of the reinforcement, we have 2H10 and the bottom is supposed to be 3H12 at the cut section and the layout of the reinforcement. By using StatPro software, we analyze the beam for its bending moment and shear force. And from the calculation, area of tension reinforcement 3H12 for the T-beam with a spacing of 339 mm shear reinforcement. Over here we have decided to use H6 350. Port at B and C, H6 350. Minimum length span BC, H6 283. Deflection allowable is more than the actual, therefore our calculation is okay. We have max allowable cracking for bar spacing at span AB and also BC. Our calculation spacing is okay. The top part 2H12, 3H12 for the bottom. The cut section, we can see the layout of the reinforcement, which is on top 2H12 and 3H12 for the bottom reinforcement.
Assalamualaikum, my name is Muhammad Haziq bin Muhammad Zalaludin Yuszaini. My metric is CF200-202. I'm going to discuss about my beam design. For specification, there are some constant value through the beam design for the simply supported and continuous beam, which are the slab thickness, unit weight concrete, brickwork properties, strength of material, and characteristic action. First, starting with simply supported beam, which the beam is A2 to A24, which the span is 4.79 meters and the size of 150 times 400. And we take the 60-minute fire resistance, which we get the C norm is 45 mm. As the load distribution is one-way slab, which produce Ly over Lx more than 2. These are the design, shear force and bending moment. For the main reinforcement, which we will use 2H20 for compression and 3H20 for the tension. So the AS required and provided is in the range of min and max reinforcement area. Next, for the link, we will use H8225 and 2H20 for the additional longitudinal reinforcement. These are the location and arrangement of V min and link. Next, for the deflection checking, L over D actual is less than L over D allowable. Also, the cracking check, whereas the limit width of crack is 0.4 mm and the bar spacing is under the allowable circumstances, and the beam is successfully without failure. Secondly, for the continuous beam, which the beam F123, which the span of 4.33 meters and the size of 300 times 400, take the 60-minute fire resistance, which we get the C norm is 30 millimeters. You can see all the load distribution is two-way slab, which they produce Ly over Lx less than 2. These are the envelope SFD and BMD, where the max value of absolute shear force and bending moment are taken for the design value. For the main reinforcement, it has tension bar only because the K value is less than the K balance value. Bar used are 2H16 with the area of reinforcement under the min and max range of area reinforcement. For the shear link at support 2A, use H8300, and also at the end of the support where the theta used are 22 degree and the additional longitudinal reinforcement is 2H16. Next, for the deflection checking, L over D actual is less than L over D allowable. Also, the cracking check, where the limit width of crack is 0. mm and the bar spacing is under the allowable circumstances and the beams are safe.